Hi guys, this is Joy. In the previous lecture of Introduction to Basic Gates, we have discussed about NOT gate, AND gate, and OR gates. Now, one thing I forgot to tell you, rather two things I forgot to tell you. What is that? That is, you need to remember the IC numbers, otherwise you can't work out with the simulation, or it will not worth anything or working in this simulation. So you need to know what is the number IC number for NOT gates, what is IC number for AND gates, and what is the IC number for OR gates. You can also find 3 input ANDs, 3 input ORs, and so on. So you need to remember the IC numbers to search from here, otherwise you can't work with or searching so many numbers. What are these, and what do they function like? And the second one is that the throwing keys of the switches can be altered by simply double clicking on these switches. You can open a simple window by where you can change the label name, that is here S0. You can give any names, no space is allowed here. And in the value key you can toggle the key here. As you can see, it can be given space A, B, C, D, F, G, H up to Z, and 0, 1, 2, 3 up to 9. Any key can be given for throwing this switch. Another one is that it has got some on resistance capability and off resistance capability. Off resistance is 100 megohms. You can increase it from here, and you can also decrease it from here. On resistance capability, more or less resistance, lesser, more the short circuited path will be created and lesser drop will be created. Now we will move on to some other gates, other basic gates, rather some important gates in digital circuits, that are the universal gates. Universal gates like NAND and NOR. NAND gates IC is 7400, and NOR gate IC is 7402. They both are quad 2 input NANDs and quad 2 input NOR gates. That means in a single IC chip of 7400 or 7402, you can have 4 NAND gates which can take 2 inputs A and B. Now for this NAND gate, I have connected S1 and S2, for which throwing switches are shown here, B and C. For NOR gates, I have used switches S3 and S4, for which I have used key D and E respectively. Now what is the characteristics for a NAND gate? NAND gate is simply an AND gate followed by a NOT gate, that is an inverter. That means the output of an AND gate is simply be inverted. That means in AND gate we got a high output for both the inputs high, so it will be simply inverted. That means for an AND gate we will get low input only when the both inputs remains at high. That means, as you can see here, both inputs are at high connected to VCC, and the output is low. If I connect any of the switch, that means pressing B or C, the output goes high. If both are high, then also the output is high. For NOR gate, what is that? NOR gate is simply, as we know, that simply OR gate followed by an inverter. That means the case of OR gate will be simply inverted here. In case of OR gate, we get low signal only when all the inputs are low, but here it is, when all the input signals are low, we can get a high signal. Only when all the input signals are low, we can get high signal. That means the throwing switches are D and E, both are low, then only we can get high output. You can check it. As you can see, only one case where you can get the output high, that is all inputs are low. For NAND gates, all inputs are high, you can get low. And here it is a very important gate, that is XOR gate. The IC number is 7486. It's a very important gate. I will explain it, but first checking the truth table or finding what kind of response it shows. Throwing switches are A and space. If I throw space, it connects to VCC, output goes high. If I throw A, both the high, output is low. Throw A again, output is high. Throw space again, output is high. And if I throw A again, the output is low. As you can see, whenever I am pressing 0 and 0, the output is low, and whenever I am pressing 1 and 1, the output is low. So it goes high whenever we have dissimilar inputs in the input logic. And that means it checks odd number of ones. Whenever odd number of ones arises at the input side, it detects it and goes high. That means it can be used as odd ones detector, which is a very important characteristics for parity generation and checking in case of error detection in transmission reception circuits of a logical circuit. Also, it can be used for several other logic converters and several other cases that will be explained later. Very important characteristics of XOR gate is that it can be used as controlled inverter. What is control inverter? Let us say A6 is my control input and A6 is my sole input. That means only one input that I am going to change. Let this be 0. Let S6 be 0. My control input is 0. Now as my S5 denotes high, that is connected to VCC, the output is high. If S5 connects to low, the output is low. That means whenever the control input is low, the circuit performs as simply buffer. Now let the control input connected to high. Control input connected to high. Now as you can see, S5 is low, the output is high, and if S5 connects to VCC, the output becomes low. That means it operates as an inverter. That means by simply controlling the control input, whenever the control input is connected to VCC, the circuit performs as inverter. That is why it is called control inversion logic, and it is very important characteristics used in binary subtractors, as the logic circuits perform all the subtraction results by performing simply addition. It simply complements the input data. That means once complementing the input data. So that is all for basic gates, introduction to basic gates. I hope you have understood all the topics very well, and if you have any queries, place on the comment box. That's all for today. See you next time.